Hello everyone, I'm Wang from Nanjing University of Post and Telecommunications. Today I would like to present the related work, Robust Few-Shot Specific Emitter Identification with Channel-Aware Enhancement, via Self-Supervised Multitask Learning. Firstly, I would like to introduce myself. I'm now an associate professor from Nanjing University of Post and Telecommunications. I'm also an executive deputy director of Jiangsu Library of Wireless Communications and IoT. In recent years, I have involved several activities in international conference. In 2025, I'm the publication chair of ICSSA. In 2024, I'm the organizing committee member of RAISI conference. In 2023, I'm the finance co-chair of IEEE SCCG. Today, I would like to introduce the background of why do this research direction. As we all know that the electromagnetic space serves as the medium facilitating wireless interactions among electromagnetic devices and acts as the primary bridge connecting diverse operational domains in the sky, air, land, and sea. So, specific emitter identification is an essential method for ensuring the electromagnetic space security. It's very important to develop a robust and adaptive SEI method to safeguard both civilian and military wireless infrastructures. SEI is a technology that's using radio frequency fingerprinting to identify different emitters. In traditional SEI-based method, it lacks robustness and it's based on large-scale labeled data size. So we need to make sure we can do the SEI identification based on few-shot and few-shot learning and efficient models, and we can get a robust result. There are three problems that we need to solve. Firstly, the problem one is low identification accuracy in low SNR and complex environment. Second problem is heavy reliance on large-scale level data. The third problem is lack of sensitivity to channel variations. This is the system model. It includes data collection, RFF feature extraction, and identification phase. The proposed SEI system compares three main phases: the data collection phases, and the RFF feature extraction phase, and the identification phase. The objective is to learn the optimal parameters M to establish the mapping from X to Y. And we named this problem as FISEI problem by introducing a large auxiliary dataset doing pre-training to construct self-supervised tests without relying on labels. And to solve these three problems, we divide the process to pre-learning, the pre-training phase, and the fine-tuning phase. Firstly, in the pre-training phase, we adopt a complex valued CNN method as the encoder. And we divide the algorithm to pre-training process and the transfer learning process. This is the simulation parameters settings. Firstly, we evaluate the result of effectiveness of transfer learning of the proposed method. The results show that it can achieve a higher accuracy across all short settings, from 58% to 91%. And secondly, we compare the result of different data augmentation methods. It shows that the proposed method achieves the best performance across all key-shot settings. It achieves significantly outperforms both individual and combined augmentation strategies. Then we compare the accuracy with the proposed method with find zero into ML and SA2 SEI and SIM CLR. It shows that the proposed method achieves the best performance. Make a conclusion. The proposed method is a novel method that integrates supervised learning, and it achieves the best reproductivity and stabilities. It achieved up to 16% accuracy improvement in 30-shot experiments, and it can adapt to the different environments. And in future work, we try to solve the weakly segment and the semi-supervised learning for level inferiority to reduce the dependence on level data. We plan to investigate weakly or semi-supervised approaches. Also, we need to develop an FSSEI framework with online adaptation and incremental learning capabilities is essential for real-time environment. By incorporating model compression and lightweighting architectures, the method can be effectively developed on edge devices with constant resources. Thank you very much for your kind attention. Thank you.